What I would like to do to really try to leverage these new CNN modifications and see what type of influence they have is to actually go back to our first CNN notebook and make them there. The reason why is I want to give them a chance to have some influence alone, and then later we'll look at combining all possible options and see what we can do to like try to get the best scores that we can. Okay, so go to your MNIST intro notebook. Okay, it was the first one that was created. Um, and I think we can probably just go ahead and run it. So if I scroll down to my model, let's see what we have here. I've got like, again, this doesn't have like really fine tuning. This is core stuff that we need, right? Convolutional layers of a certain size with a certain kernel size. It's like the size of the filter. Got the input shape, there's a couple max pools and flattening it out at the end. We have a predefined number of epochs, which is 20. And it looks like the last time I ran this test, it was good. It was strong. I mean, it was hard to do better than that, right? Test score equals 98.5. So if you have the test score up, great. You don't have to rerun this, but for sure run everything before to load it. So go to runtime, run before. Okay, and I'm going to make some changes now. So one of the changes I'm going to try, and this is the full data set it looks like. See, I see that here using the X shape. I don't actually want to use the full data set yet because I don't know, I want to do a lot of different tests and it just takes longer. So remember how to fix that? Go up to in, and that's why the score is better. Go up to in rows and you can set it equal to, I mean, we did the 2001 often, it's fast. I think I've also done 2500. I'll do 2500, give us a little more. And it's a balance, right? It's a balance for class because what you're going to find is that, right, when you put in more rows and more data, the more of effect these things can actually have. Okay, but let's go ahead and change that for now. On your own, change it back. That's also the advantage of showing things like your shape here. So I'm going to do it again, runtime, run before. And now I'm going to think about what to change here. In fact, though, I will say this, because I'm changing it back, I'm going to go ahead and run an initial model too to see, refresh myself, because that 98.5 was with the full count. Let it run, but I can go ahead and pick, padding equals same is the first thing introduced. I'm going to try that. Okay, I'm just going to change both of these to padding equals same, and let's see if there's any difference. Will it be better or worse? I mean, the numbers are generally centered toward the middle, so it's not necessarily going to be better. You can see it's building here. If you look at the image up here, it's hard because it's not bordered, so you can't really see, but obviously there's a lot of empty space in these pixels. So I'm expecting, some of these expectations are true, that padding will have negligible, but hey, it could be wrong. And I think padding equals same, when you have like a full photo with a lot going on, it can be a good idea. I'm going to go ahead and try it for both. Padding equals same. And do you want to scroll down and see what type of score did I get here? Well, 98%, still good, right? So it wasn't a huge gain. All right, so I like too that it's, by the way, exactly 98% here. So that's easy to compare. And the other thing we had looked at was, recall this one doesn't show the validation accuracy. It just shows the accuracy of the training score each round. Okay, but let's just roll with this. All right, so I'm going to run it again. Got padding equals same. Give it a minute. We'll see. I think with padding, we don't need to like isolate these or anything like that. It's not even like that. I think we want to use average pooling also. So I believe it should go in the layers, right? Because because we're adding. If it's .add, it's a layer. Now it's running, so I think it might not give me the prompt. You can always do it in a separate cell if you really needed it. You know, is it average pooling 2D? I don't have it on that. There we go. It is average pooling 2D. So average pooling 2D. Yeah, the names aren't perfect, right? Max pool, average pooling, but they both have the 2D in there. And then you should be able to, we can change it, right? So instead of max pool, let's try average pooling. And again, because these numbers, like the visuals are so basic, I'm not expecting much here. But when you get to more interesting images, I think, you know, you're going to see some effect here, right? As mentioned in slides, if you're looking for subtleties, you know, average pooling makes more sense, I think, than max pooling. I'm not sure about with this data set. But the point here is more that we see how to do it and we see what effect it is going to have. So we're still running on this one. And it's finished, so it's yet not as strong, right? 96.8. And again, that's not surprising because it's giving like the edge pixels, which are most likely white, a little more influence. You know, if you're seeing that, it just makes me want to get rid of padding same because I think it's just not going to be good for the MN IST. And then, yeah, I'm just going to get rid of it. Okay, so I've got some intuition with experience, but let's see if average pooling, and again, I'm not expecting it to, you know. And one other thing, by the way, on these scores is that there's an element of randomization with like hey, what are the first weights that it gets to? So one score isn't the be all end all, right? If it's really close, something worth considering. But you can see that's how you would add the average pooling of 2D. The other two pieces that we want to bring in here are the strides and the dilation rates. Okay, and these are just here, right? Like it's a kernel size of 3. I mean, these are 28 by 28s, so it's only so much, right? A kernel size of 3. When you do a stride of 2, right, that's skipping over a lot, but it could learn from it. So I'm just going to change it. Strides, because it's plural. And I think 2, you know, I don't think we want to go more than this because it's small. And you know, you don't have to try it in 2 places. You could try it in 1. You could experiment, you know. In case you're wondering, this parameters can be in any order. How did this one do? Wow. Like 99%. Oh man. I think that might be the best score yet that I've had. You guys may have had better, but wow. You almost want to run it again and see if you get the same thing. So in this case, average pooling did work better, right? Without focusing on what's the brightest, what's the average. Cool. And that's interesting. And by the way, just thinking, I'm trying to think like why maybe it's worth trying to sometimes, where you have an intuition and then you have the results, and then you can like, you know, rethink the reason why. Well, if I go back to my image, it's kind of interesting because if you have edges of the number, they're going to be defined better with average pooling as an edge, right? Because it's going to include some of the white space to bring it down. So that's interesting. All right, let's see if strides equals 2 does anything for us. I don't know about you guys, but I think this is fun. And I think it's like, this does not seem to be helping because the accuracy is, you see how it's going really quickly too because it's cutting down. Yeah, it's just not enough. It's not enough because what we're doing is we're losing like half of the data. And because we're starting small, and we have a small number of like convolutions, it's not helping. So what we're going to do is double the convolutions. And then let's see if that makes any difference. Okay. So think about that, right? If you have strides of 2, you're basically having half as much. And if you're starting with big numbers, you know, definitely worth trying. But I'm just going on how I think it's fun here. You can see it is gaining, so it is learning. And it could be that we don't have enough epochs here, right? Because if it's steadily learning, then we're in effect cutting it off too early. See how it keeps going up? I want to do more, right? Let's give it more chance to learn, double the number of epochs. And then we see some of the advantages, some things we're not doing right, which is, getting it to stop at the best score, just keep going if it's not working. And the way deep learning really is designed, it's designed for small gains, right? It's not like a 40 epoch type of idea. It's more like a 4,000 type of epochs or more. It's like little learning goes a long way in deep learning. I've mentioned this a lot, but yeah, you just got to keep it in mind. Like our theme is to cover stuff in class, shorter amount of time. This is interesting, right? You can see that the learning keeps going up here. And right, like look at the accuracy. It continues to improve. I'm not going to push it further right now, but I would encourage you guys to go wild with this. Try 400 and try the early stopping. And we will look at combining everything. Okay. So it seems like the strides equal 2. There's potential there, but it's like slowing things down now. Let's try just switching it with dilation rate of 2. You can see it shows up as an option. And one other idea is you don't have to match these, right? Maybe you're like, well, I just want to try one dilation rate. So there's really a lot that you can have fun with here. Got an error. Oh, you see the error here? Sometimes I just look at it, like I look at it and something jumps out at me. If you're not used to things jumping out, then it can be tricky. But that should not be a double equal sign. That's wrong. Try it again. Okay. I'm a little curious to see how this one starts based on the others that we did. You can see it looks like it has a similar theme, right? Where it looks like it's taken a little longer to learn, though not quite as long as the strides. Oh, and I didn't change the epoch, so this is going to be interesting to see with 40, right? Like, will it, see there a drop, like, will it continue to gain? And, the early stopping is going to be looking at the validation set. It's going to drop when the validation set doesn't improve, okay? Right, because it's not so much the accuracy improving. We've seen that you can't get 100% accuracy. It's more like, yeah, but how well is it going to test on a model that it hasn't seen before? So this is interesting. Like it's seeing some gains. I'm a little curious to see what it does when we get to 40. So I think that actually covers all of the new pieces, right? We've got a lot to play with here. We've got strides and dilation rates, average pooling, and padding, right? So good stuff that you can use and try. And we're also seeing how, the number of filters like can actually have an influence over what you change, right? Because again, strides half as many parameters, well, you're potentially losing learning there. Okay. Before we combine it, let's see how we're doing here. It's about to finish. Yeah, so accuracy got really high, but again, big question is like, what did the test score do? Pretty good, 98.4. Pretty good. So dilation rate. These all look like worth pursuing for this data set, except for padding equals same, I would say. The others are showing some strong potential. So there's not a one size fits all for machine learning. There never has been. And what I mean by that is I can't give you like ideal instructions, be like, well, if you combine these two in this way and these three in that way, you're guaranteed to get the best results. There's simply too many options, right? So you just got to kind of try and experiment. But I'm going to try and experiment too. So I'll show you some things that I've seen and that I would like to try. And I do want you to keep in mind that my general expertise, I would say, is in foundational machine learning. Okay. I am not an expert in building CNNs. I know how to build them, as you can see. What I do is I do research and teaching, and I try to like facilitate the learning process for you all. I say that because I think what we want to do here is not just learn from me and from your peers, but you can learn from others. Just to show you, like when I was doing research for this class, I'll throw one in right now, okay? You know what? I'm going to wait. I'm going to split up the lectures. I will do it first thing in the next one. We're going to look at techniques that others have used. And my hope too is that you all can share, okay, after this upcoming lecture, some techniques that you all use to get great scores, right? And I'll show you what I've seen other people do as well. Keep up the great work.